Hello everyone. I have been getting many comments from all of you to solve the model question paper, VTU model question paper. So I have tried to solve few numericals from the first set of question paper, that is in that first question paper. Okay, so I have covered few problems in this. I hope it will be helpful or useful for you. So the first question which I have solved is question 3C. Determine the resultant of the force system acting on the plate as shown in the figure. Okay, so first what we need to do is, here 80 Newton, 60 Newton inclined forces are there. We need to resolve them. So it will be 80 sine 45 and 80 cos 45. Okay, and 60 Newton horizontal component 60 cos 30 and vertical component 60 sine 30. Okay, then after resolving this, first we need to find the algebraic sum of all the forces in x direction. I have solved and uploaded like this because there was a limitation of the time, as you were all asking it to upload very quickly. So I am uploading like this, and in the upcoming days also I will try to solve as many numericals as possible from all the model question papers and upload. Okay, please like, share and subscribe to my channel and keep following my channel and share with all your friends. Okay, so sigma fx equal to, first it will be this 100 Newton horizontal force, 100 plus this horizontal component, that is 80 cos 45, plus this one, that is 60 cos 30, so 208.53 Newton. This problem is very simple. Then taking the forces, summation of all the forces in y direction. So first is positive upwards, that is 60 sine 30, then this is minus. Okay, this one is minus, so 80 sine 45 minus this downward 100 Newton, it will be minus 126.56 Newton. So we know that r equal to square root of sigma fx square plus sigma fy square. Then we get r equal to 243.93 Newton. Then direction is theta equal to tan inverse of sigma fy by sigma fx. Substituting and simplifying, we get minus 31.25. Then taking moment about point A. Okay, so 80 cos 45, it will be causing a clockwise moment, that is 80 cos 45 into 3. Okay, plus this clockwise moment 150. Okay, directly it is a moment, so 150. Then plus this 160 cos 30, it will cause a clockwise moment about point A, so 60 cos 30 into 3. Okay, the perpendicular distance between the line of action of the force and the point which you are considering. Okay, so that is 3. 60 cos 30 into 3. Then plus this 100 Newton, that is clockwise. Okay, about point A, 100 into that distance is 4, so 100 into 4. Then minus this one 60 sine 30. Okay, this force, it will cause anti-clockwise moment about point A, so minus 60 sine 30 into 4. Okay, then that is 755.59. next you can find x intercept, y intercept as the sigma ma by sigma fy. Okay, though it is minus, you have to take that is positive only, that distance. Okay, so sigma ma by sigma fx, fy you get x and y intercepts, that is 5.97 meters and 3.62 meters. Then d you find it as sigma ma by r resultant, so 3.09 meters, that is the distance. This is a very simple problem. Next problem is problem 6th C. This one 6th C. This problem, that is determine the moment of inertia about x axis for the shaded area. Okay, we have to find the moment of inertia of only the shaded portion. Okay, that is we have to add the rectangle. We have to split this entire figure into, first is rectangle, then this triangle. Okay, rectangle, triangle and circle. Okay, first we have to add everything, that is rectangle, triangle and subtract the circle. First let us find the areas of each rectangle, that is b into d. So it is 75 plus 75, 150. 150 into 50 plus 50, 100. So 15,000 mm square. For triangle, half base into height. So half base is 50 plus 50, 100. Height is also 100, 5,000 mm square. Circle area pi r square. So r is 25. So minus pi r square, because we want to subtract this one. We want to find the moment of inertia of only the shaded portion. Okay, so minus 1963.49. Now we have to find the distance of the centroid of the each area, CG of each area from the x-axis axis, right? So for the rectangle, it will be distance it is given, that is 75. That is center of this rectangle. This point is at a distance of 75 from x-axis axis. So this is 75. Then for the triangle, we know that distance of the CG is at 2/3 from the apex and 1/3 from the base. So we want x-axis is at the base. So it is 1/3 of this distance, that is 100, 33.33. Then for circle, again directly it is given, that is it will be 75. Okay. Next is simple. We have to find AY square, that is area into Y, that is 15,000 into 75 into 75, like that, AY square. Then IX bar, that is BD cube by 12. B is 100, D is 150, 150 cube by 12. Okay, 100 into 150 cube by 12. Then for triangle, we know that again AY square we have to find. Then it is B into D cube by 36. Both B and D are 100 and 100. So 100 into 100 cube by 36. Then for circle, we have to subtract it. Okay, that is, we know moment of inertia IX bar, it is pi r raised to 4 by 4. So r is 25. Okay, then what you get? Total area you have to find. Then we have to find the total AY square. Then summation of IX bar we have to find. Okay, here into 10 to the power 6, that is not visible over here. So IX bar is equal to summation of IX bar plus summation of AY square. Okay, so substituting and simplifying, we get IX bar equal to 109.477 into 10 to the power 6 mm raised to 4. Okay, then next one, question 5b, that is locate the centroid of the shaded area as shown in the figure 5b. Okay, again here what we have to do is we have to subtract this. Okay, circle, that is first find the rectangle 1. Area is 120 into 80. Okay, this is 120 and this is 80. We find the area. Then semicircle, that is pi r square by 2. Pi into 60 square it is given. Semicircle radius pi r square by 2. Then for triangle, it is half base into height. Base is 120, height is 60. So 3600. Then for circle, minus pi into 40 square it is given, radius 40. So we find the total area. Then we have to find x and y values. Okay, that is distance of CG of the each component from the x and y axis, right? So x is for first rectangle, if we take, we know CG would be at the center, right? So this x distance, okay, it's C distance of its CG from y, that will be 120 by 2, so 60 mm. Okay, and from x axis, that will be y, it will be 80 by 2, that is 40. Then find AX, AY, that is area into x, area into y, AX, AY. Then for semicircle, what is the distance? X distance, this is 120 by 2, that is 60, and y distance, this you know that it will be 4r by 3 pi. Okay, then plus 80. Okay, for this semicircle. Okay, this is 4r by 3 pi, semicircle 4r by 3 pi plus this distance is 80. So 80 plus 4r by 3 pi. Then find AX, AY. Then for triangle, we know 1/3 of 120. Okay, if you are taking, that is you want x value, right? X value if you want, then 1/3 of 120. Y value if you want, 1/3 of 60. Okay, then find AX, AY. Then for circle, what is the distance from the y axis? That distance is 60 because 120 by 2. And from y axis, the distance is 80. Okay, this is 80. Directly it is given. CG of this circle, the center of the circle from the x axis, right? So 80. So you have to subtract the circle. Okay, that is, you have to add these values, subtract this value, add these values, subtract this value. So summation of AX, summation of AY you get. Then again next is simple, x bar, y bar, that is summation of AX by summation of A, y bar is summation of AY by summation of A. You get x bar equal to 54.81 and y bar is 14.24. I want all of you to solve again once again. Okay, all this solve and practice, then only you will be perfect. Okay, and it is very simple subject. If you are thorough with your basics, then you will not have any problem. It is a very scoring subject. Okay, don't get scared. Then Determine the smallest force P required to just move the bottom block if top block is restrained by cable. There are two blocks given, weight 100 Newton, that second one is 1500 Newton. Okay, first if the top block is restrained by cable AB, this cable AB, if it is restrained, okay, then mu s and mu k are given. Mu s means coefficient of static friction, mu k is coefficient of kinetic friction, right? So let us take the first case, okay, that is free body diagram of the blocks when top block is restrained by the cable AB. Okay, I have drawn the free body diagram. This top block, its weight is 100 Newton. We will get the N1 normal reaction, then 0.3 N1. Okay, then the tension in the string AB. Then for the bottom block, it will be N1 downwards and self weight 1500, and this will be N2 from the floor. Then this is P. Similarly, here you are getting at the floor and between the contact surface of top and bottom block, you will get 0.3 N1, at bottom you will get 0.3 N2. Next simple, we have to do sigma Fy. Okay, that is upwards N1 positive minus downwards 100. So N1 is 100, taking summation of horizontal forces, that is 0.3 N1, it is this direction 0.3 N1, and this is opposite minus T. So T is equal to 0.3 N1, that is N1 is 100, 30 Newton. From then the for bottom block, sigma Fy equal to 0 for here. Okay, you take summation of all the vertical forces, that is positive N2 upwards minus downwards N1, then 1500 is downwards, so minus 1500. We have found out value of the N1 already, that is 100 Newton. So what we are getting, N2 is equal to 1500 plus 100, that is 1600. Then taking summation of horizontal forces, that is this side P positive minus 0.3 N1 minus 0.3 N2. Then we get P equal to N1 and N2 value we have to substitute, that is 100 and 1600 respectively. So we get P equal to 510 Newton. Okay. Then next is second case, that is cable AB is removed. Then how we have to solve? 1 second. Yes, so if you are solving for the second case, then I have drawn the free body diagram of the blocks. Okay, when cable is removed. Okay, then there is no tendency for the relative motion between the blocks. Okay, so there is no friction between them. So if you are taking now the top block, you are getting only the self weight 100 Newton and this N1 upwards, right? And for bottom block, what you are getting, 0.3 N2, okay, and N1 and 1500 Newton and upwards N2, and P again doing sigma Fy equal, that is N1 upwards minus 100, N1 is 100. Then for bottom block, sigma Fy equal to 0, N2 minus 1500 minus N1, so N2 equal to 1600. Then sigma Fx equal to 0, that is positive P minus 0.3 N2, you get 0.3 into 1600, that is 480 Newton. Then I have solved this last 9th B problem, that is of the projectile. If it is fired with a velocity of 60 meter per second on horizontal plane, then they have given 3 cases. I have solved for 2. I think you can refer those and solve the last one as well. And please mention in the comment section the answer for the third case. Okay, it is very simple and interesting problem. So what they are given, find the time of flight if its range is 4 times maximum height. Yes. So for the first case, we know that the horizontal range r is equal to u square sine 2 alpha by g, and maximum height attained is u square sine square alpha by 2g. Time of flight is 2u sine alpha by g. Okay. So if r equal to 4 h max, substitute the formula for r and h max. Okay. So what you are getting, u square sine 2 alpha by g for u square sine square alpha by 2g. Okay. Then u square gets cancelled, right? G gets cancelled. Then 4 by 2 you get again here sine 2 alpha equal to 4 sine square alpha by 2. Sine 2 alpha we know 2 sine alpha cos alpha. You should know all these trigonometric operations. So 2 sine alpha cos alpha equal to 2 sine square alpha. Then sine alpha and here sine square alpha, 1 sine alpha gets cancelled. So you get sine alpha by cos alpha, that is tan alpha equal to 1, alpha equal to 45 degree. So time of flight t equal to 2u sine alpha by g. Substituting u equal to 60 and alpha equal to 45, g equal to 9.81, you get 8.65 seconds, that is time of flight. Then h max is equal to 4r. U square sine square alpha by 2g is equal to 4 into r is u square sine 2 alpha by g. So sine square alpha equal to, here g gets cancelled, u square gets cancelled. Then sine square alpha is equal to, sending to this side, 4 into 2, that is 8. Then sine 2 alpha is nothing but 2 sine alpha cos alpha. So sine alpha by cos alpha, sending cos alpha this side, sine alpha by cos alpha, you get 8 into 2, 16. So tan alpha equal to 16, alpha equal to tan inverse of 16, alpha equal to 86.42. So time of flight t equal to 2u sine alpha by g. U is 60, alpha is 86.42 divided by 9.81. Please all of you solve all these problems. Okay. So you get time of flight equal to 12.2 seconds. All these problems I have solved to the best of my knowledge, and I will upload the remaining problems as well in the upcoming videos. Okay, please like, share and subscribe to my channel, and I wish all the best to all the students for their examination. Thank you.